Okay, Unit 5, Day 8, we're going to look at factoring and solving regular polynomials. We're going to use a graph to help us. It's kind of bringing in a little bit of last unit, and so Unit 4 and Unit 5 kind of collide here today on this stuff. So some of this will be review stuff from last unit, but our learning target, I can factor and solve a polynomial equation of degree 3, so cubics, or higher, given enough roots factors, or help with my grapher. So we're going to give you enough hints that you can get the ball rolling. So you may not be able to factor right off the bat, just by looking at it, but there is a hint in there somewhere that you can use to kind of get the ball rolling and see what some factors are. So remember a binomial. So if you have a binomial ax plus b, that if that's a factor of a polynomial, or is a factor of a polynomial, if the value is 0 when x equals negative b over a, which is just subtract b and then divide by a. So if this equals 0, it's a factor. We kind of knew that already. A number is a root of a polynomial if, when you plug it in, so when you plug it in for x, I'll put 4x, the y value is 0. So a root and a 0 are the exact same thing. So down here, what we're going to do, we're going to give you this cubic. And if I just said factor this guy, factor it, you couldn't. There's not enough there to factor it. But if I tell you that x minus 1 is one of the factors, that helps get the ball rolling. It'd be like if I told you a really big number, 5,208, and I said factor it, but you're struggling to find one, and I said, oh, by the way, one of the factors is blank. Well, you divide by that and you get a smaller number, and then that smaller number is easier to work with. So I'm going to divide by this factor so I have a smaller polynomial to deal with. So my first step here, I'm going to take this guy and I'm going to use synthetic, because synthetic's so much faster for me at least. So I'm going to do, remember the coefficients, now we have an x cubed, x squared, x, and no x's, so there's nothing missing. Everything's present, every exponent's present. So 3, negative 5, negative 3, 5. And remember out here, I was told that x minus 5 is a factor. That means 1 is a root. Because what would make that equal to 0 is a root. And I already know, because I've been given this a factor, this better be 0. When I'm all done, that better be 0 in the end. If it's not, I messed up. Because if it is factor, when you divide it, you don't have a remainder. And that last column is always a remainder. Okay, so let's start this synthetic division. Remember, drop the first number down. So 3, and now multiply. So 3 times 1 to get the next number. Someone's going to add straight down, multiply to get the next number. So add straight down, multiply to get the next number. Add straight down, multiply to get the next number. Add straight down, and I got a 0 like I was supposed to. Now what I have left, so remember, what you have left, it still needs factored. So this polynomial, these numbers represent the polynomial 3x squared minus 2x minus 5. So x minus 1, again in factored form, x minus 1 is one of them. I divided that out. Now I got to try to factor this further, and we could try, most of these, almost all of these will be factorable at some point if we're just saying factored form. Now we say roots, sometimes you have to use quadratic formula. So if this is a 3x squared, I'll say 3x and x. Remember, these two need to multiply to give me negative 5, but the outer product plus the inner product equals negative 2. Okay, so products of 5 would be 1 and 5. So I could try, I'll use a pencil here first, I could say 1 and 5, and this is a minus, so I'll say minus plus. And I have to use pencil because I might have to erase it. So the outer product is 15, the inner product is negative 1. So 15 minus 1 is not negative 2. Okay, so I'm going to switch these guys now. I'm going to put a 5 here and a 1 here. So 3, because 3x times 1 is 3, the inner product is negative 5, so 3 minus 5 is negative 2. So that's the one I want. So that's the winner there. So now in factored form, it didn't say solve it, it said factored form. The other factors are 3x minus 5 and x plus 1. So be careful on this guy. Don't forget, the factor they give you, make sure you include it. Okay? I also want to quickly look at the graph of this guy. So I'm going to type it in the calculator. Type in the calculator, hit graph. And look at this graph here. So it goes somewhere over here. So it goes up. I'm just going to sketch it real quick. Looks something like that. And if you remember, these guys right here tell us what the zeros are. The multiplicity on all of these is 1, so that's why I went through all the zeros, or it went through. There was no touches and turns. Now at positive 1, there's a 0. At negative 1, there's a 0. This would actually be 5/3. So this is where you switch the sign, divide by that. Up here, the negative b over a. So the opposite of b would be 5 divided by 3. So 5/3 is a little bit less than 2, and that's why it went through there. So that's just a quick sketch of the graph. So the graph, if I had, instead of giving you this, and I just said, here's the function, here's the graph, I could look and say, well, negative 1 is one of the zeros, so I'm going to divide by negative 1, or 1 is what one we use then. So any of these you see, you can use and kind of get the ball rolling. Okay. Now that you have factored the above polynomial, I need to solve it. So now it's equal to 0. It's not just a term here, it's equal to 0. So that means x minus 1 times x, 3x minus 5 times x plus 1 equals 0. So what makes each one equal 0? Here's 1, here's 5/3, and there's negative 1. So those are my zeros then to actually solve it. Okay? Now, this one, again, we're just factoring here. So given that 2 is a root, instead of saying the factor is x minus 1, I gave you a root, which is essentially the same thing. Okay, it's the same information, it's just how I'm going to use it here. So if 2 is a root, that means x minus 2 is one of my factors. So right off the bat, there's one of my answers. X minus 2 times, I got to figure out the rest. So let's divide by 2. And there's nothing missing, so 1, 2, negative 7, negative 2. Add straight down. Multiply, add straight down, multiply, add straight down, multiply. Oh, I did something wrong here. What did I write wrong? Oh, right here. 4 times 2 is 8. So that makes that a positive 1, which makes this a positive 2, which makes that a 0. So there, I knew I was wrong because this wasn't 0. So I wish I could say I did that on purpose to teach you something, but that was just me being a bozo. So this is the polynomial that's left. Once I divided and got that root out of there, this is what's left, which remember, that's an x squared plus 4x plus 1 that's left. Can't factor that guy. Okay, so we can look at, could I factor it? No numbers multiply to give you 1, because the only factors of 1 are 1. The fact that this is positive and that's positive means this has to be positive, and those don't add together to give you 4. So this is not factorable. So x squared plus 4x plus 1, that's actually irreducible. You can't go any further with that. So there's the factored form. Now, same function, we're supposed to go ahead and solve it. So solve for all 3 roots. There are 3 roots in there. They may be real, they may be imaginary, we don't know, but we do know one of the roots is what they gave us. They gave us 2, so don't forget that one. Okay, you're going to feel really silly if you forget that one, so don't forget to write that one down. Now, the other 2 roots are in this. So x squared plus 4x plus 1 equals 0. So think back, how could I solve that if it's not factorable? Well, there's always complete the square, which I think you're crazy if you want to do that. But quadratic formula is always there to save us. So I got my a, my b, and my c. So negative b plus or minus the square root 16, because b squared minus 4 times a times c all over 2a, which is 1, over 2 times 1. And this ends up being, let's see, negative 4 plus or minus, it'll be a 2 on bottom. And it looks like, because this would be 16 minus 4 is 12. This equals 12. I can pull 2 out. There's a pair of 2's in there, so I can pull a 2 out, and there's 3 left. And now that I've got this radical simplified all the way, they're all divisible by 2. So this would be negative 2 plus or minus radical 3 over 1. So I'm not going to write the over 1. So the other two solutions is -2 plus radical 3 and -2 minus radical 3, because plus minus on that one. Okay? Let's flip this guy over. It says that to the right, there is a graph. And this is a quartic. So it means there's 4 roots in there. They may not be real. They may not all be real, which if I look at the graph, how many times across the x-axis? Just 2 times. That means there's 2 real roots. That means the other 2 are not real. They're not actually there, but there are imaginary roots. So there's going to be 2 imaginary roots. When I get down to here, there's going to be 2 real ones and 2 numbers, or 2 I numbers. So what are the real roots of this polynomial? So if I just look at the graph itself, it looks like it crosses at, and these are going up by 2s, 2, 4, 6. And the other one looks like -3. Now, maybe I'm not sure. It looks like it, but what if it's actually like -2.49 or something like that? Well, let's find out. We can check by doing that polynomial division or synthetic division, and if it has a 0 remainder, it was a factor. Okay, so I'm going to start. So nothing's missing. So 1, -3, -14, -12, and -72. And we can just start, I'll just start with 6. So first number, drop it down. 1 times 6 is 6. Add straight down. Okay, and I got 0. That means 6 definitely was. Check, 6 definitely was. Now I can use what's left. Okay, and just ignore that 0. I can keep going with my synthetic divisions. Now I'm going to use -3. So drop the first number down. Add 0, 0, 4, -12, 0. So it turns out -3 was also a root. Now, what would happen if I did -3 first and then 6 second? I would still end up with 1, 0, 4, 0, but my intermediate numbers would be different. But in the end, I would get zeros on the end, and I would have found out the exact same thing I already found out here. So nothing new there. So my factored form, I'm just going to start filling it in here. X minus 6, x plus 3, because I found that those roots. And now what's left, this guy here is x squared plus 4. And you could use quadratic formula, complete the square, all those things. But this one would be easiest to use square roots, because I have an x squared but no x. So this one, if I just set that equal to 0, and when I go to square root, uh-oh, can't do it. Okay, so on this one, that means this one is not factorable. It's just x squared plus 4, and that's it. Let's see, so down here, if I want to go ahead and finish solving now, okay, so my solutions are the 6 and the -3 from above. Don't forget those. Just copy those down. We already found them. And those are from the graph. We just looked at the graph and saw them. And then what's left here, let's keep going with this. X would equal plus minus. Remember, if there's a negative under there, then there's going to be an I in my answer. And what's the square root of 4? 2. So real solution, that's where it crossed the x-axis. But now I've got these other 2 guys hanging out, this 2i and this -2i. Those are imaginary, and that's why they don't show up on the graph. Okay, but they are there. If I multiply all of these, if I wrote these back in factor form, multiply them together, I do get the original function. So I know it's true. They don't exist on the real number plane that we're looking at.